Hello, everyone. Welcome to today's lecture. We'll be talking today about essentially making the web pages that we've been writing or that we discussed how to write come alive using different technology. We'll start off with like an introduction to JavaScript, like what is the language like generally. And then we will go into like interactive manipulation of the DOM using the standard API, look a little bit at events. And then finally, we will have like a first steps in D3. And so what we'll be covering this lecture is essentially what you will be needing for homework 2, which will be released today or tomorrow morning. I'll first, if there's any questions on last week's material or any organizational questions, I'm happy to take them now. Okay, if not, we can just get started. I'm sure many of you, like all of you, have like worked with programming languages. I'm sure some of you and many of you have already worked with JavaScript. It's kind of like this whole lecture here is kind of like assuming that you know object-oriented programming and maybe functional programming. And I'll just hint at some of the differences between JavaScript and related languages. So one thing that you should do is like go to the website like dataviscourse.net/tutorials and then follow along here. You can play with this yourself. And then you should also immediately open up the console. And so like there's a lot of output here. And what you can do in the console, let me also zoom into this here, clear, like calling the clear function will clear that up. And then you can kind of see what exactly is going on for any of the examples I'll be showing. Okay. And one other thing to note is that JavaScript has been kind of like a language that had a bad rep for a long time. And I think this is kind of partially justified, especially in the early days of JavaScript. But I have to say that the ECMAScript 5 and more recent ECMAScript 2016 are actually pretty good. There's a lot of like cleanup happening, but there's still some kind of like idiosyncrasies in the language that you have to be aware of. So like, why do we want to use JavaScript? Well, we've so far have only created static HTML and SVG code. So if we, for example, wanted to create a bar chart with 15 bars that updates depending on like a data set that we'll be loading, that would be impossible. Or like if we wanted to create a bar chart like that, we would have to write like 15 rect elements and position them manually. And clearly what is like get an array of data and then map that to some property of the bar chart to automatically generate that bar chart. So like using something like JavaScript, the programming language allows us to like dynamically create these charts. And then we can also reuse those charts, or we can interact with them. And so this is really what computer programming generally is about, like interactivity and reuse. So we can tell a program to do something for certain classes of legal input, and then it will do that for all of these cases. And so JavaScript is the language of the web. It's kind of the most important language of the web. It's not the only one, though. Like, for example, you might have heard of WebAssembly, which is kind of like a new technology to bring other languages to the browser. So I haven't seen a ton of pickup. People still use JavaScript a lot, but there are certain advantages to using WebAssembly. We won't be talking about it in more detail. And like back in the day, we also had alternatives such as Java applets or Flash, but these are now like virtually extinct. So there's barely any Flash websites that use Flash anymore, and Java applets are like almost impossible to execute nowadays. So JavaScript is kind of the de facto language of the web. It is mostly used on the client side of client-server applications, but you could use it on the server with languages such as Node.js, where other languages such as Java and Python are also popular on the server. But we will be like this course will be essentially front-end only. This is just like a decision to keep it simple. We don't want you to like have to like tackle multiple languages at the same time and running servers and so on. And so this will just be front-end only. So the coolest part about JavaScript is its tight integration with the DOM. And so this is what we'll be getting at later in this lecture. But on this page here in this JavaScript introduction, we won't be doing that. But this is kind of like really when we want to dynamically manipulate websites, this is really where it's cool. OK, so JavaScript can be used in, it's kind of like a multi-paradigm language. You can use it imperative, procedural. You can use it in an object-oriented way, or you can use functional programming styles. And we kind of combine all of those to kind of use the best of all of these worlds. It's also a dynamically typed language, which means that like you actually don't have to define the data types of your variables. These are just like assigned by JavaScript as it goes. This is kind of weird maybe for people who come from strongly typed languages such as C, C++, or Java. Personally, I like in my research group, most of my students and I myself now prefer to work with TypeScript, which is kind of like a strongly typed JavaScript version, and that you can transpile into JavaScript for the browser to run. And a lot of TypeScript features have also influenced the development of JavaScript in the past. But we'll stick to the vanilla JavaScript in this course because A, it's getting better and better, and so the need for TypeScript isn't quite as important anymore. And B, like you still need to know JavaScript if you want to do anything on the web. And then another like weird thing about JavaScript is that it uses prototypical inheritance instead of a class-based model. What that means, I'll revisit this later. We now have some kind of like class-like concepts, which were absent actually before ECMAScript 6. And so we can now do class definitions, but behind the scenes, it's prototypical, which means like I have an object prototype that I can kind of like copy and so on. But we'll go through this slowly at the end. So that's kind of like the high-level introduction about some property. But now let's look into some like how do we get started. As before, if you, so these kind of like code windows here, they are interactive. But if you like to run them, you just have to change anything in them. So if you want to rerun something, you can just like hit like a space, and then it will rerun, and you can see that the messages here appeared on the right. And so the first thing is like you want to be able to write something to the console, right? So console.log does that. I can put out like text, or I can put out numbers, or I can kind of like access a constant that is like in the math package here. So fairly straightforward. I can also do this, which I'll be using a lot. So I can multiple variables into that function, and all of them will be printed. JavaScript has variables like any other programming language that hold values. So here are some kind of examples. And this is interesting because of the different scopes here. So first, we have global variables. And so if I don't specify anything, like just say A is 0, then A is now defined as a global variable for the whole program. I can define A B as a string here, like the string with the number 1. We have arrays, as we do in other programming languages. I'll talk more about arrays a little bit later. Here's another array. You can do arrays of different data types. So you can do this like number, string, array, nested in an array. This isn't something that you typically want to do. So this is usually bad style. Arrays are really meant to be kind of like of one data type. It's possible to do it. There can be sometimes a good reason to do it. But generally, like if you want to do something like this, maybe an object is a better thing. We have booleans, like here, f is assigned to false, and then we have like some a type of operator. So we can, in this case here, I'm checking f's type. I'm saying, let me clear this again. So in this case, I'm asking what is the type of f? The type of f is boolean. I can then, interestingly, redefine f as a float stored as a number. So here, like we take the same f, we don't have to change anything. We can just redefine it. And now f is, in fact, a number. So this is the number data type. It doesn't, like you don't really distinguish between integers and float here. So this was all global variables. And like, as you know, if you have taken a programming course, global variables are kind of tricky. They kind of like pollute your namespace. They like it's not necessarily clear when they are modified and so on. So what you should really do is work mostly with local variables. And so there are three different types of local variables: vars, lets, and consts. And var is kind of like the old style, like all JavaScript before 2015 used var for local variables. And nowadays, this is kind of discouraged because it has function scope, which is kind of weird because for most programming languages, we expect variables to use block scope. I have an example exactly what that means a little bit later. New in ES6 is like the let keyword, which is a local block scope variable. So I can say let age equals 36. And so this is kind of like now a local variable, and this is the way you should mostly be using it. And then also new in ES6 are consts. Const nationality here would be Austrian. And note that these is like also in most other programming languages, you can't redefine this, but of course, like if you like have a complex data type here, the data type itself remains mutable. So this here will throw an error, a runtime error. So here you have an uncaught typed area assigned to a constant variable. Of course, I can do this, what I just said earlier, that if I have a complex data type, they're still mutable. Here I'm assigning an array to test. And here, like I'm showing my original array. This is 2, 3, 4, which is as it was defined. But I can change the values of tests. So const is really just like you can't reassign it, but you can still modify a complex data type. OK, so I think I have covered all of what I wanted to say here. OK, so now let's take a look a little bit more at what I mean by like a block scope versus function scope versus global. So we have like no identifier creates a variable of global scope. Var creates a variable of function scope. That means that the only way to isolate a variable is to wrap it in a function. And so if you have like an if statement and define a variable in that if statement, it is visible outside of that if statement. Whereas let creates a variable of block scope. And so here, if you have defined a variable in an if block, then it's actually not visible outside of the if block. And const is just like let in terms of the visibility. So let me show you what I mean here. So here I have a demo for a function scope. I define a variable a. Then I have an if block, which is always executed. Here I define variable b. If I run this, you will see that I actually can access both variable a and variable b in function scope. So I can actually add this up. And this is kind of really not what you want typically. So this is kind of a very unique aspect of JavaScript. And this is kind of like can lead to confusion. It pollutes namespace and so on. If you use a let, that is not possible. So let a is 2. If true, here we define let b is 3. And now we can't actually use it. So we can, if I were to run this statement here, I would get like an uncaught reference error. So let b is not defined, and this is exactly the behavior we want. And this is why we should be using like the let expression instead of the let keyword instead of the var keyword. What we can also do, and this is something that you can easily like stumble upon, you can define a global variable inside a function. So if you just forget the let definition here, I'm actually like defining this variable here globally within that function. And so I can actually access, like I'm just executing this here. And then if I, like you can see, if I run this again, let me see, take this out. Yeah, so if I run this again, I actually can access the 3 that I defined in here outside in the global scope. So this is something that kind of like you're leaking essentially a variable into the global scope, and you really don't want to do that. So the right way to do this here would be to do that. This here still shows the 3 because it's still stored, but it's actually referring to a different variable. So if I did global x here and then global x, then we would get an undefined error. Okay, any questions so far? Okay, sounds like we're ready to go on. So general rule, always use let, never use var, and minimize your use of global variables, and never ever define global variables in a function like I just showed here earlier. So like any other programming language, we can execute operations on these variables. There's again MDN documentation on different expressions and operations. So we can do like simple math, simple like additions, subtractions. We can use the shorthands that we are used to. Sum plus equals 1 adds 1 to the value of sum. We have sum plus plus, which adds 1 to the value of sum. A sum minus minus, which removes, like reduces it by a value of 1. We can do like divisions. We can use the modulo operator that essentially gives us the remainder. We can use the type of operator, which I already showed earlier. Here, like basically, well, I'm just printing this. So we can look at we can look at what is a type result and as a string in that case. We can do string concatenation. So here is how I would like concatenate 2 strings, which is very convenient. And then we have to worry a little bit about parsing and casting, because when we read data from, for example, a CSV file, typically it's not available directly, or it's not automatically parsed as a number. So we have to explicitly parse that. And so we can do that with this parse in function here. And so we can look at int here is like shown at 13. You have to be aware that like in the console, if something is a number, it will show like in blue here. This is of course something specific to Chrome, but this way you can tell whether it's a string or a number. And I can do the same thing for floats. So I have parse float here. I can works the same way. I can also do a parse int on a float string, which will simply like parse it into an int. So kind of like use only the most significant, like everything before the comma, that converts this float to an int, like 17 here. And I also have a shorthand. The shorthand parse here converts, like this is the plus sign, and it's something very convenient that converts that string to a number. And then I have my number here. Okay, then we have arrays. We kind of like introduced them briefly, but like here I want to go a little bit more into depth because they're like they hold data and they are very like useful, of course. And arrays in JavaScript are really more like lists in Java. So they are very unlike these low-level arrays because we can we don't have to pre-allocate a size for an array. We can dynamically extend it and so on. So it's closer to Python, for example, than it is to something like C. So you have you can simply define a numerical array this way. You can define an empty array like this. And then we can access an array just as we are used to from other programming languages by using like the index, which always starts at 0. You can, but as I already said, you should not use arrays of different type, like with elements of different type. So this works if I log that here I'm logging 15 and this, this and true. So the data types are preserved, but yeah, not very elegant. You can access the length of the array using the length attribute of the array. So here I'm showing you the length. You can nest arrays at arbitrary depth, and you can then access them with like this nested syntax here. And you can extend arrays with the push function. So this appends the 3, like the integer 3, to the end of the num array that we had up here. I can remove the last element from an array, which then also returns it. So if I wanted to just retrieve the last element of an array, I can use the pop function and then can assign it to a variable here. I have functions such as the index of functions, like index of 21 will return the index position, which I'm printing here. So the index of 21 for that particular array is 2. And then I can sort. And so question, what happens if I were to sort this number string up here? Like this. Also, the weird thing about JavaScript is that it sorts by string. So we, by default, if we put like num_array here, if we create, like if you just call that sort function, we will get like this sorted as 12, 15, 21, 3, 4. So this sorts them as strings by comparing those strings. And it starts with like, these start with 1 and then have the lowest digit in the second place. So 12 comes before 15, before 21, before 3, before 4. But if I sort a numerical array, this isn't what I want to do. And so what I need to do here is I actually need to pass in a little function that gives, that essentially tells us how we should sort something. And so we simply pass in, like we write a function compare numbers that takes two parameters, a minus b, and then we return a minus b. And that is kind of like, if they're equal, that's 0. If b is larger, it's negative. If a is larger, it's positive. And so that way we can, like the sorting function can actually evaluate that. And if we do that with compare numbers, we can now actually sort them as numbers as we did before. So like there's two things here that are happening. Well, one thing that is happening first, I'm passing in a function as a parameter. So this is kind of like one of those things where JavaScript's functional character shows. And we'll talk more about this later. And the second interesting thing is there's also like a shorthand for this. I'm here writing like an anonymous function, like a lambda expression with the arrow notation. And so I'll talk about this a little bit more. But this here is exactly the same. Like this line here does everything that these couple of lines here do. So I'm saying like create an anonymous function with the parameters a and b, and then return the value by b minus a. So this is a little bit, let's say, like a unique syntax maybe with JavaScript, but once you're used to it, it is very handy. And so we'll be using this quite a bit. In this case here, this is a reverse sorted array because I'm subtracting b from a as opposed to a minus b up there. Okay, so there's lots more you can do with arrays. Again, I'm linking here to the right place to read about this. So definitely take a look at this because arrays are important for data visualization. So the second data structure we'll be looking at are objects. And objects are kind of like also in JavaScript dictionaries or hash maps or associative arrays, whichever term you prefer. So they're kind of like this multifunctional data structure. And I can define an object like this with curly brackets, and then I have my key and values here. So this is like a, right now, this is like a structure in let's say, C++. And then I can access an object with the familiar dot notation. So I can say value of key, in this case here is object dot key1. So that's great. This is really like the way we would expect it. We can also access object with a string key. And so here, like object, like this is now, this shows more like, this looks more like a hash map, right? So basically we can store the name here in a variable and could pass it in. And so this is kind of like, we're using this more like a hash map than we do. If you're using this to access objects, you should, like fields in objects, you should generally always use this notation as opposed to this notation, because this here is robust to refactors and so on. So if you were to change the variable name of key1 somewhere, like your IDE, if you use an IDE, will be able to like refactor that. But that here, like that is not usually, like you can do it and you can refactor it, but you can't do it automatically because it's a string, right? It's not clear that this is the this is actually pointing to that key2 in the general case. So we can also, because like this already hints at that, we don't have to use we can define these keys here also as strings, like we have it here. And that kind of starts looking a little bit like JSON. And so you might have seen JSON before. JSON is this JavaScript object notation data format that is fairly common nowadays for, like, say, complex structured data. We can extend objects dynamically. So we don't have to kind of like define everything about an object by the first time we create it. We can also at any time later say, here is my other object, and I want to add a new field to it. And I can dynamically add that new field to that object. And so we can see that the value of the new key here was successfully added to that object.
Sir?
Yeah.
How are you running individual cell blocks when you have them highlighted?
I'm just like in this example here, I'm just hitting the space.
Cool, thank you.
Like change anything in the cell and it will be automatically re-executed.
Okay, thanks.
Sure. And note that, like, unlike for arrays, objects containing mixed data types are a perfectly good coding style. This is really actually what they're useful for, right? So here, like, I have defined an object person that kind of describes me, like my name, my birth year, my nationality, and the countries I've lived in. Yeah, this all should be fairly familiar with these like unique caveats about JavaScript. Now, since we talked about objects and about like JSON a little bit, I also wanted to show quickly how we can work with JSON. So JSON is, as I said, this JavaScript object notation. And so here here's an example of me defining this. This is like a text file, right? So I'm writing this in a text file. So this is data. And I have like, I start my JSON with like, here's my curly brackets that also can already indicates, hey, this is an object. And then I create a people array, which you see by the square brackets here. Then I have another, like in the people array, I have an object. And that object here, in that case, is what I just had, a person object. And then here I have another object in that array, in this case for Jen. And in that, I have like this nested list of countries that she or I lived in. And then we can read this into JavaScript, and it immediately becomes available as an object. So we don't have to do like anything like parsing or like assigning this to fields. This just creates an object that I can just work with in JavaScript. And so that's why working with JSON and JavaScript at the same time is very convenient. I'm not going to go into the details here. This is just some code that you can copy and paste if you need to load. JSON, we'll talk about some of these concepts, but a little bit more complicated. It's not that important. Like the point here is that I simply can kind of like, I fetch this JSON file, and then I can actually like just access these fields. I can say person data, the first person, take its name, and this is what we see here. And we can also log like in this case, I'm logging the whole data set, and I can then like in the console, like kind of like inspect the data that I've just loaded. And so you can see this is really like a proper object now. Okay, so next we need to think a little bit about control structures, like if statements and loops and so on. And JavaScript comes with fairly standard conditional control structures. We have like ifs and switches. There is, of course, we always need to look at equality tests. And so what exactly is equal, what is true, what is false, and so on. This is like, I'm not going to cover that because it's fairly usual, right? So like a 0 is like evaluates to false, like a negative number evaluates to false. A positive number evaluates to true, and so on. Like an empty string evaluates to false. You've seen all of this before in other courses. But one thing that is unique about JavaScript is kind of like this differentiation between double equal and triple equal signs. So if I want to test for equality, like here, I'm testing if 1 equals parseInt of the string 1. And that should evaluate like to true. And so this is in fact true. And we can see that like console again, like this here is the value, the first if. So this is what we're logging here. So this is evaluating the true. And this isn't evaluating, like this would be, here we are doing the shorthand cast, and here we have an else. So if I were to change that, then I would get the else here. But one thing that's like, I've used this triple equal sign here, and generally you really want to use this triple equal sign because the triple equal sign is essentially is like a strict cast or a strict check for equality. So it doesn't do any type coercion. But if you do just the two equals, then you will actually get type coercion. So this will just parse that for you. So here you see that this actually evaluates the true if I just do two equal signs. And that's kind of like something that most other programming language wouldn't do. This here wouldn't now, this doesn't evaluate because now this automatic casting doesn't happen. And so we actually just found like a bug that in one of our research projects that was really like a big deal and was caused because of type coercion here. So an empty string, like a null was coerced to an empty string and then was evaluated. So you should always use the triple equal sign for strict casts. And if you need to cast, do the cast explicitly. So this is never being executed because it is a strict cast. And so you should instead do that explicitly. As in other programming languages, we have the ternary operator for if conditions. So we have like a condition, which is true here. What happens if the condition is true before the colon here? And what happens if the condition is false after the colon here? So you've seen this also in other programming languages. And then we have our typical switch statements where I have like I is some case here. Here I can use string literals. And in this case, it will match this particular switch here. I do have to use the break, or like in other languages, because otherwise it would kind of continue evaluating. And if I don't use the break, the default would be also evaluated. So if I, here we have some case, so if I remove that, we should actually see the default as well, because the break doesn't terminate it. OK. Loops also have some kind of like idiosyncrasies. The standard for loop that we like know from other languages with indices works just fine. So here I have like let I equals 0, I smaller than 10, plus I, and then I'm writing it. So this works just fine. While loops also work just the way you would expect them. So here I have a while loop and then a condition, and then I'm printing that. Let me just show the output here. So we have our kind of for loop output here at the very top, our while loop output. We also have the do while loop that is very similar, with the one difference that the do part here is always evaluated no matter what happens in this condition in here. So this gets evaluated at least once, and then the condition is evaluated. And so these two are very similar, with the exception that this has to be true for this to ever be evaluated. This is always evaluated at least once, and then this condition is checked, and it keeps evaluating until that condition is false here. So now what we frequently want to do is we want to loop over a data structure. And this is where JavaScript is a little bit different from other languages. So you've probably seen more advanced languages like Python or Java. They do have like these for each loops. And JavaScript didn't have like a proper built-in for each function or functionality before. Instead, what you had, or like a while ago, but instead what you had to do is to like use an array. Like here I'm looping over an array, and what I would do is I would use the for each function of that array, and then pass in like another function as a variable that does something with the data. So the D here, and we'll see this frequently in D3, the D here is being passed into this anonymous function and kind of corresponding to the element that I'm currently inspecting. So in the for each loop here, in the for each function here, I'm actually printing those years 54, 49, 81, 82 in sequence because I have passed in this anonymous function. So that used to be the way that we used to write JavaScript for each loops. Fortunately, now we also have this for off loop. And this is kind of like what you have also in other languages. So you can say for let year of years, which is kind of like more readable than this up here. And it works for all kinds of iterable data structures. And then you can console log your years like that. And so this is a great way of doing this nowadays. This is still an acceptable way. I personally think this is more readable. And then there is also the for in loop that kind of looked like a for each loop, but in fact is not. And so the for in loop is something that you typically don't want to use. First, it loops through an object's enumerables. It doesn't guarantee order. And so for lists, this is really not what you expect. So if I do for let year in years, what you kind of like thought is that year here would be the year, right? Like this number, but it's actually not. What year is in that case here is that 0. And so that's kind of the object key. So it's actually looping through the indices in this particular example. And so to actually access the year, you would have to use that index to access that value. So first, that's pretty odd, right? Especially for an array. So you don't really want to do that. Second, the order isn't guaranteed. It works here, but there's like could be different between different browsers, so don't count on it. And then third, this is really mostly useful if you want to like look at all of the properties of an object. So here I have an object that has properties A, B, and C. And then if I do that, I can say for property in object, and then I could log the property and like the key and the value like that. So here I have my A1, B2, and C3. So this is where this is useful. Like you might not need that all that frequently, but you can. Here you can actually do that. Okay. So
there's a question from
Sure.
Garrett.
Yeah, I had a question on the first loop. If you were to, so like, that one, could you like apply that function? So let's say you use this and your function ended up being like the year plus 1. Would that change the years to like 1955, 1950, 1982, 1983?
There's a separate apply function for the array to do that.
Okay.
So this, I'm not like 100% sure, but I'm assuming that this doesn't actually modify the value. But there's a separate apply function that does exactly what you're saying.
Perfect. Thank you.
Yeah. Okay, so we've used functions, and now let's look at how can we actually create functions. And so functions are, of course, this super important principle. And like here is a simple example how we create a function. We write function keyword, then we give the function its name, then we have round brackets where we put in parameters as many as we want. So this is very familiar. You can do something with that. And this here function, essentially, if the number is smaller than 10, it returns it. Also, it returns the number multiplied with itself. So not particularly exciting. So what's happening here now, like we can call this function just as we would expect. But the weird thing is that JavaScript, again, this goes like is a theme. You have this weird type coercion happening. So here I'm actually passing in a string, but JavaScript will just try to convert that to a number. And since this can be converted to a number, it will actually return that. So function for a string that can be converted to a number actually returns a number. So you would, like in another programming language, I might even say in the same programming language, you might actually get like a runtime error, right? This type isn't compatible with what you're expecting here, but I haven't defined a type. So this is really hard to do in JavaScript. And so that's why it's also just casting it and trying to do that. So here I have I'm calling this function with a string that cannot be converted to a number, like the what string here. And so what it's assuming is, well, you were actually, like, again, no runtime error. So what it was assuming, it's, oh, you meant undefined. So it just returns not a number. And then finally, what you also can do is you can pass in multiple parameters. Like you can use a function signature that doesn't actually exist. So here, like my function signature has only a single parameter, but I can pass in multiple parameters. I can pass in as many as I want, and JavaScript will not complain about that. It will just ignore everything else that it doesn't know. So it will assume that, well, I don't know what exactly it will assume, but it essentially is going to ignore everything that it doesn't understand, which is kind of like a potentially error prone, especially if you have override functions with different signatures, then that can be problematic. And you can also, this is even weirder actually, you can also call that function without any parameters, and then it will just assume that you meant undefined. So yeah, this is kind of like awkward if you come from like a stricter language like Java, but it has sometimes advantages, but it also is kind of awkward sometimes. So none of these call runtime errors, and JavaScript will simply ignore extra ones. You can call it with too few parameters. Yeah, if you have any leftover parameters, it will just define them as undefined. So this is kind of like the function definition here is fairly straightforward, but then we can also, like we had used this before, when we say, hey, we want to use functions as variables, this also goes as far that I can define a function like this. So here I'm saying let, like I'm defining a variable, and that give the variable the name variable function, and then assign a function to it. And I'm actually doing like this with a full-on function with multiple lines and so on. And this works just as expected. So I can kind of like here pass in this variable. I can also later reassign that function. So if I change my mind later in my code, I have variable function now is supposed to do something completely different. I can do that. I can just reassign it. I can say function of x is return x minus 5. And so now when I call the same function again, just a little bit later in the code, because it was redefined, first it returns big, which is kind of like what you expect here. And then it returns like what this expression here returns, which is a number 25 in that case. So this is kind of like actually really powerful, because we can kind of like pass in not only variables into other functions, but we can pass in functions into other functions. And we will be using this a lot. We will be using especially a lot of anonymous functions, or as they're also called, lambda abstractions, especially when we'll be working with D3. And so we've already done this before when we were sorting. We kind of like did this even with the arrow notation. But now I'm going to go through this a little bit more slowly. So here I have an array. And then here I'm using the map function, which is actually similar to the apply question we earlier had. So it's actually map, not apply. I'm taking the map function, and then I pass in a function that simply like doubles the value. And so if I now like execute this, you can see that the values of this array have been doubled. And so here, this is an anonymous function. It's called an anonymous function because it has never been given a name. So it's just like pushed in directly. And so this is you can also call this a callback parameter that is then used in this map function itself. And since this is super common and very frequent in JavaScript, ES6 introduced this shorthand notation for them, these arrow functions. And so this is like now a function definition, an anonymous function definition here. I'm doing the same thing as I did up here. I'm doing this with just the arrow notation. So my numbers.map d and then arrow d multiplied by 2. And so d is simply like the parameter of that anonymous function. And then here, that statement here is the return value, d multiplied by 2. So this is very succinct, and this is also very readable once you get used to it. So this is kind of like the preferred way to write these short anonymous functions. Generally, if you need to write longer functions, it's better to actually do that here, and then have like an explicit curly bracket. We can assign arrow functions to variables too. So for example, here, this is kind of awkward syntax, but it essentially says f1 is a function that doesn't take a parameter and always returns the value 12. So this is a very complicated way of saying f1 return 12. I can write a function here, like this is like my function that takes a value x as a parameter and then multiplies this x by 2. So now if I call f244 here, I actually get the value 8 as my return value. Here I have a function with 2 parameters that uses the arrow notation. And we actually can like also use the curly brackets to have like a more complicated statement here. So here I'm saying I have these x and y parameters of my anonymous functions. Then I'm doing something here to my x and y. And then I can use it as I would expect. And the result here is f2 for 3 and 4. In this case is 12. So again, slightly awkward syntax if you're not used to it. Generally, if it's such a multi-line thing, you probably want to just like go like spend the extra couple of keystrokes to actually write it like this. Might be more familiar to some people. Okay, before I move on to object-oriented JavaScript, are there any questions so far? Yeah, go ahead.
Yeah. So in this F3 example,
Yep.
is X and Y, are they modified at the end of this function?
X and Y
Like-
are parameters, right? They're not modified. Well, I'm
Okay.
modifying them in here, but they
Correct.
are like. So are you asking whether I'm passing something by value or by reference?
Exactly.
Okay. JavaScript behaves like most other programming languages. It like low-level data types are by value, and more complicated data types are by reference. But you need to double check me on that exact syntactical detail.
Okay, cool.
Yep. Okay, so there was another question? No. Okay, so now let's talk about object-oriented JavaScript. And I'm going to show you kind of like, because you might encounter it, but this is kind of a neat way I can actually do object-oriented JavaScript without ever using the word object or ever using, like I can actually simulate object-oriented programming just using functions. And so this used to be the way we were doing it. So here would be like a function create object. And then I'm like defining a variable result, and that result is an object that has these attributes, and these attributes are actually functions. Because we can now, functions can be attributes, we can actually recreate object-oriented programming without actually like using the syntax that we use from other languages. So here we have a get, a set, and then a twice, which multiplies a value with 2. And so now we can say like create object. We do that with something, and then we this is then stored in f, and then we can say f.get, and get returns something. I can say f.twice, which is not a number because I passed in a string. I can then say f.set and put in like a number in this case. And then if I later retrieve f.get, we see that this variable has been updated. I now have my 20, and then I have the twice, which now in this case works. So that's kind of like a little bit weird to read. And so there are now, let's say, there's now syntactical sugar on top of that. But this is how this still works behind the scenes, like how the browser still understands what is going on. I can also use this like to do inheritance. So if you like in Java, you can like inherit from a base class. You can do that too in JavaScript. So for example, here I have like my base class and my base object and my derived object. And what you actually do here is not actually inheriting stuff, but it's prototype delegation. So every object in JavaScript has a pointer to a prototype, to like a higher level object it's defined, it's derived from. By default, that's empty, but you can set that. And you can set that with this set prototype of function. So let's like look through this first. So here we are accessing the base object here, base v1. And that is exactly what we expect. We can do that. We can access v1 in the derived object, which is not yet derived. So these are two independent objects. And then derived v2, I can't actually access that. This is undefined. Like this isn't like, since we don't have set up a relationship between those two so far, this is undefined. Now I can set the prototype. I can set the prototype of the derived to the base. And so now I've kind of like created something like inheritance. So derived v1 is now accessing the value v1 that was overridden here. v1 is the same as v2 here. So this one here is accessing and returning the 5. Whereas this here, derived v2, is now actually kind of like accessing the element from the base object. And so what happens behind the scenes is that the object, the first object that you're actually calling, derived v2, says, hey, I don't have that field. Let's look at whether any of my parents in my parent hierarchy have it. And so it drops it to the prototype object. And if the prototype object has that particular value, it will return that value. And so this way we can kind of like implement inheritance here. So this works as you would expect. And then finally, in ECMAScript 6, we have gotten like familiar class syntax. So here is like a base class. We have a constructor keyword that we can pass in. We say this dot first to assign this to the like object variable, and we can assign those two variables here. And then we have like a classical method, and we can like do something in that method. And so now we create this new base, and we can use it exactly as we would expect. And now what's nice, so we do something like this here, exactly what we had hoped for. And now we can also derive, like we can do this extension that I did manually with prototype delegation up there. It's now the same thing here. So I can say class derive extends base. And then I have my constructor where I take 3 parameters. And I'm passing the first and the second parameters to the super, so to the base class here. So this calls that constructor. And then I'm setting my third variable locally here. And then my multiply, I'm overriding my multiply to also include the third variable. And so this is kind of like familiar to everybody who has done Java or C# or C++ or something like that. So this is kind of like very similar and fairly easy to use in that sense. And so this works just as expected. So nowadays, this is the way you would do object-oriented programming in JavaScript, but you will still see like a fair amount of code if you look back that did things like that here. Great. So one thing that you will maybe run into eventually is the problems with this, and you sometimes see that this is renamed and stored in a variable. And so this here refers by default to like the object that you're in. So this is kind of useful for things like the setter function or accessing the variables of your object. And so that's great. But there's one unique thing about JavaScript. And so all of this here works as expected. And so you don't have to worry about this in that case. But this in JavaScript is bound to the calling object. Or not the calling object, but it is bound to, well, it assumes the context of the calling object. And so what does that mean? So here is yet another object that I'm creating with this function kind of signature. I have like a variable x3 and then a getter function. And now if I like initialize this, and then object.get will exactly do what we expect, like it retrieves this.x. But now I'm doing something that is perfectly legal because functions can be variables. I'm assigning object.get to another variable, t in that case. But here, now the context of this is different. So now this is actually not working. We get this undefined behavior here because it's like this is now its own object. What this here actually refers to is not the yet another object, but it's the global window object, and therefore it's undefined. So that's kind of like a tricky bit that you can sometimes run into. So if you have something like that happen, make sure that you like have the right context for this. Okay, so I've listed some other noteworthy things in JavaScript, but those are not particularly important to understand and work with JavaScript. They make programming JavaScript more like convenient. So I would recommend that you just look over them yourself because we're kind of like running short on time. And one other note is like browser compatibility. Can you write modern JavaScript, ECMAScript 6 or later, and then apply to other browsers? And sometimes you can by simply doing what's called transpiling. So you would have like a build system that takes in your advanced JavaScript code and then compiles it down to equivalent old style JavaScript that older browsers can use. So here, this is like an arrow function that would be transpiled into something like this here. So something you might want to do in a real life environment. But for now, let me kind of like jump ahead and, given the advanced time, move on to like this first steps in D3 piece, because that's kind of like the key thing that you will have to be able to do the homework. So let me give you like a quick introduction in D3. D3 stands for data-driven documents, and D3 is a JavaScript library for manipulating the DOM based on data. It's based on a paper that was published at the Viz conference, which is kind of like the main visualization conference by like Mike Bostock, Vadim Ogievsky, and Jeff Hare. And Mike Bostock is still the core developer of the D3 library. And so D3 it can be used to manipulate pure HTML, but it's very commonly used in combination with SVG. So we'll be using it very frequently in combination with SVG. And so the really cool piece about D3 is that it kind of like uses basic web technology to associate data with DOM elements and then render them in a smart way that you can control. D3, like up to last week, version 5 was the latest version. There was just a release to version 6, which isn't all that different, but there was a big difference between version 3 and version 4. So we will, like in this lecture here, I'll be using version 5. We might update some of our later homeworks to use version 6, but don't expect anything that I'm talking about today certainly is exactly the same in version 6. Okay, so like what is unique about D3? And now we have, now we are kind of like back in like combining, like this is how I would like write a little bit of like, this is all HTML until I have my script tags here. And then in here, I'm suddenly writing JavaScript. And I'm actually writing D3 code here immediately. So what you see in my HTML, I have defined 2 paragraphs. Here's a paragraph and one more. And then I'm taking D3 and say D3 select P. And so this is the same thing as we did with CSS before. we select elements based in this case on the element name. And that is then stored in this paragraph variable. And in this paragraph variable, I can apply a function to this. Like I can say dot style color steel blue. And so this is the only place where I'm defining a color. And so you can see that this is actually like this takes the first element of type P and then applies that style. So this is the result of that. So this D3 select and it's kind of like big cousin select all is this very powerful thing where we can like use these CSS selectors, including like classes and IDs and elements and also like parent and child relationships and inheritance and so on. We can use that to select any element on a website that we want. We've used D3 style mode, but we could also use well, we've used the style attribute here, but we could use also the generic set attribute method that would just set any attribute. So you could like set attribute href in, and then put in a link here in the second parameter of that function. Okay, so D3 selects the first element, and selectors can be like specific tags or classes or IDs, as I already mentioned before. And so here is like I'm using a selecting by tag, the P element. Here I'm using selecting by ID. And this again uses the same notation as we did in CSS. So we have like hashtag second is element second here with the ID second. And I'm setting that to teal. And then here I'm selecting by class, D3 select dot other, and set this to dark orchid. And so that's what I noticed, that I have two others here. So select only selects the first one. So it only applies it to the first class. But this way now I have kind of like styled using all of the three different ways of selecting elements. So like for classes, of course, what we actually, in this case, it would be much better if we style all of the classes dot other with the dark orchid color. And we can simply do that by using select all instead of select. And so if I do that, here I have my first paragraph, which has an ID second. Well, it doesn't really matter for this case because I'm just saying D3 select all on paragraphs, and I set all of them to steel blue. And so now I've kind of like programmatically changed all of these variables with JavaScript instead of with CSS to steel blue. So what is kind of cool here is that I haven't used a for loop, right? So in like a traditional like non-functional style, you would expect that I would say PS is an array of elements, and I would write a for each element in PS set style color steel blue. But that's not what D3 does. It uses this declarative approach. So essentially, these collections that you get returned from select all, you can bulk apply like all of these different things to all of the elements. So what you really try to just like be smart about your selection, and then in one single line change all of the elements in your selections at once. And so typically you can actually write very complicated D3 programs without ever using a loop. And so if you catch yourself writing D3 code and writing loops, then you're doing something wrong. You can do it, but it is not very, it's usually not succinct, and it's clearly not the way D3 is meant to be used. So let's take a look at here. We can in this example, I'm showing you that I can not only style stuff, but I also can change things. So for example, here I'm appending, like I have my 4 paragraphs again, and I'm appending a span element to it. And then in that span element, I'm adding text. And the result of this is that I've actually now significantly modified the content that was in that HTML. And so now I'm actually starting to dynamically generate websites. So I'm like, this has been specified only once, and now it appears 4 times here in this website. This here now is just like a brief code snippet that will allow me kind of like to dynamically run something, because now it's going to get interactive. And so this code snippet here is included in all of these examples here, and it calls this execute function, and then runs everything that's in this execute function. So if you ever wonder what this is this function, and all this does is to allow me to do this, that I have this button here, and I don't have to write this code all the time. So it's included here. OK, so now let's look at how can we use D3 to manipulate SVG. And so this is really like where we want to go. So here we have an SVG element with 3 rectangles. And we have the 3 large, like 1 large and 2 smaller rectangles here that are not particularly beautifully placed and have like some odd shapes. And now if I wanted to make them into a bar chart, I can do that with D3. So what I would do is I would call D3.select all rectangles. And now P contains D3 rectangles. And then I'm setting attribute X, which is the position, to 0. So all of them after that call will be like on the left here at 0. Then I'm setting attribute Y using like an anonymous function, as I just introduced it earlier, to pass in a function for the attribute Y. And there I have 2 parameters, D and I. And the names of these are arbitrary, right? What really matters is the position. But by convention in D3, the first element here is always D and has the data. And the second element is always I and is the index of the elements. And so I'm actually not using the data element because we don't have any data elements here. I'm only using the index element. And I'm saying return I multiplied by 90 plus 50. So I'm kind of like positioning the Y in stages. I'm saying like the first element starts at like is at index 0, so that starts at 50. The second element is at index 1. It's at 90 plus 50 at 140. The second element is at 180 plus 50, and so on. So this is like a way of dynamically specifying the positions here. And then like we had this anonymous function definition like this. Here is the same thing with an arrow notation, right? So I'm dynamically specifying the width. Again, I'm making every successive bar chart wider or bar wider here. So and the result of this is we start out with like a smaller bar, and then this one moves down and is bigger, and then this one moves down and is even bigger. So any questions so far about this? OK, so we haven't used any data so far, but the key feature of D3 is really mapping DOM elements to data. And so there is a special data function in D3 that does that for us. So we have our kind of like setting up our SVG again. And then here is where we really want to look at the code. So D3 select all SVG. I'm picking the SVG here. And then on the SVG, I'm calling another select all, and I'm selecting all the rectangles that are in that SVG. And then now we are like this here is like a data structure that contains these rectangle objects. And now we are binding data to them. We say dot data and then pass in an array. And now I can use that data to do data-driven styling. So I can say, like I have 256 values, and I'm not using them until the width. So I want these bar charts to correspond to the width of the data that I have in that array here. And this is what I'm doing in this line here. I'm simply saying width is exactly the value that is bound to that particular element that I'm looking at. So D, and I just return D. Just straight up the same. Like the width should be exactly that value, or that value for the second element, or that value for the third element. And the rest of it is just as in the other example. And now when I do that, I actually get data-driven styling. So I have now these 3 rectangles that are size proportional to the data I have up here. So if I change that, for example, to, let's say, very big and very small, you will see that this, in fact, immediately works. So I have my large bar and my very small bar. And so this is kind of cool, because now we've done data-driven styling for the first time. And this is like how we can actually create a bar chart. But even like what is happening here behind the scenes. So let's look at the, like I'm actually logging the rectangles here. And this data structure here contains in the group, here we have our 3 rectangle elements. And so we can look at these 3 rectangle elements here, and we see that this rectangle, this is like an SVG object. So it has like all of these different attributes. But now we can keep scrolling, and eventually we will find this object here. Underscore underscore data underscore underscore is 127. And this is where D3 is storing that data for that object. So if you ever do data binding and something isn't working right, this is the way how you can see what data is bound to which element. So you can inspect that. You can also just like right click on an element here in the inspector, and then it will drop you in, and then you can actually explore that more if you want to. OK, so what happens if we have more data points than we have elements? So here I now have, let's close this again. Here I have four data points, but I still have this like SVG with only 3 elements. And so if I just like, this is the same code as above, so I haven't changed anything other than added this one number, and this is just like not gonna work. So if I run this, the 4th element isn't taken care of. And to kind of address that and to dynamically add new elements to a page, we need to like use the enter function. And the enter function essentially does for like all the elements that don't have a matching element in the selection, they create automatically a new object that you then can manipulate. So again, I have my 3 rectangles. In this case, I have my 4 data points. Here is the stuff that we did before. And this here is the new code. So here I'm saying selection.enter. And now I have selected all of the elements that didn't find a match between the selection and my data. So those 3 here were actually matched up successfully with elements in this selection here, but this one wasn't. And I can retrieve this one element here by saying, or any more that I might have, by saying selection.enter. So now I'm actually like operating on these elements that are not yet mapped to DOM elements. And then I'm saying .append rect. Now I'm creating essentially the rectangle element, and then I'm setting attributes for that rectangle element, and I'm just initializing it with like some constant values, 10, 10, 30, 30 in green. And so if I now run this, you will see that I have 1 green square in here. And so now I have these objects. And now here's a question for you. What will happen if I click run again?
My guess is that it would make another green square.
No, it won't, because in this case, it actually already has that rectangle. It will create a 4th bar.
Does that 4th bar go to the front, the beginning of the list? Or,
no, it goes to the end here. So I'll show this again. So I'm running it once, I get the green bar, and then I'm running it again. And now what is happening is that like I'm not working with this anymore, right? I'm now working with what I dynamically generated in the website here. And so this now matches all of those 4 rectangles. And now I can bind every single data element. And so this here is actually empty because there's no enter selection, because I've successfully matched all data elements. And so
is that because the SVG got updated?
Exactly, because I updated the SVG when I executed it for the first time.
Is there a way to skip that intermittent step where you see the green box?
Yes, that's the next code box. Yes, of course there is. We kind of like don't want to have to like do that all the time. So I'll show you how to do that right now. Any other questions? Is that clear? Okay,
what if the number of list elements was smaller than the number of SVG elements?
That is like 2 minutes later. In 2 minutes, I'll come to that.
Cool.
So first, here's one approach of fixing that problem, right? So one approach is just copying that code down here, and that will work. The only difference between those 2 pieces, between the enter and the append, is that I'm still showing the one green and the other one blue so that we see the difference. But this works. Of course, copying code is never really an elegant solution. And so what we can do instead is we can use a merge command to merge those two selections. And so here we do select all on the rectangles. On the data, we have one element that is not in the selection, in the existing selection. So what we do is we say selection.enter.append rectangle. So here we're creating the rectangle, and then we merge the whole thing with the selection. So now this selection here contains all the four rectangles. 3 of them have pre-existed that I defined here. 1 of them was dynamically generated just here. And then I can do my data-driven styling just on the whole selection. And this is kind of like now a very succinct way of doing that. And now we have kind of like, we can skip that intermediate step with the green rectangle. So that's kind of like, this is how you would handle this. And this is very, very common, right? Like you actually frequently want to start out with an empty canvas. Like here, my SVG is empty. And most of the time, this is going to be like you start with something that's empty and you generate everything dynamically. And so here I'm doing that. I'm simply saying I'm enter append rect, and I don't have anything else. I'm actually not even running a merge. So I'm generating everything here out of thin air. One interesting aspect here is that the rectangle piece, I'm selecting on something that doesn't yet exist, right? I'm saying select all rectangles, and there are no rectangles. So what would happen if I do this? Well, it actually works. So what you select on here doesn't, strictly speaking, matter, but you should never do that. Like you should always, like this kind of makes it very brittle, because if you want to use that function later to update it, then that will break. So you should always, like if you're creating something of something new of a certain type, you should, even if you don't have it yet, you should do the right selection up here. And I saw once one of the co-authors of D3, Vadim Milgievsky, give a talk, and he said, like, you don't have to do it, but I will personally hunt you down and shoot you if you don't do that. A little extreme, but yeah, it was his opinion on that. Okay, so now let's explore what happens when, like, the question we had earlier about removing elements. So we have, in this case, we only have 2 data elements, but we have 3 rectangles. And so if I run this naively with the code that we had before, what will happen is that this one big element here will just stick around. Of course, that's not desirable. And so as you can imagine, with the enter selection earlier, there is an equivalent way with the exit selection. So I can say SVG select all rectangles, map the data to it, then I style my elements, and then we have an exit selection we can call selection.exit.remove. And that then removes all of the elements that were not matched to this data object. And so around now, we actually like successfully removed that element. And so if I have both an enter and exit and an update, then I can like kind of take care of any possible case. So just to recap, this is kind of like how this works. We have existing elements in this red circle here, data elements and that we want to like map to these elements in the blue circle here. And then we have data that matches to elements. This is our update selection. Then we have elements that don't match the data. This is our exit selection. So you want to remove them. And then we have data that doesn't match the elements. We want to create them dynamically. That's in our enter selection. In D3, there is like a new way to handle selections and data with this join attribute that essentially just says, this is very similar, but it just like simplifies this, all the 3 enter, exit, and update selections into a single thing. So now I'm actually like, I can have 4 or 2 elements in here. And just by calling the join, it's going to work just fine. So this is kind of like a nice way of doing this. And this is a fairly new feature. It's still important to be able to manipulate those separately, because you might want to specify in what exactly you want to do. For example, to do transitions. So here is a way of how I could do that. I can actually, in the join, I can define like what happens with the enter and the update. So here I'm just like the difference in the join that I'm doing here is that I'm making one green and one steel blue, but otherwise those are the same. And so the result of this is that I'll have one bar that is newly entered in green. So generally, I don't find that particularly readable. If you want to handle enter, update, and exit separately, I would just do like this, what we've done before, treating them separately and then merging them. I think that's the kind of nicer approach, but you can do it like this too. So like, I just want to like quickly show, and I'll kind of keep stop now, because this is already everything that you will need for the homework. But I'll just show some of the examples as a teaser for next time. We can now generate transitions very easily. And we can also do this for lines. And so for lines, like with the path, there's special functions and so on. But we'll talk about all of this next time. I think this should give you like a solid foundation for the homework. We will also have a lab that reviews those concepts, because I'm sure this was kind of like a lot just now. On next Tuesday, since Monday is a holiday, we moved the lab to Tuesday. And then we will be kind of like looking at this and some more advanced features in the next technical lecture in more detail. And we'll also look at events and how to deal with events in one of the future technical lectures. OK, anybody have any questions before we close the lecture?
I guess I have sort of very logistical question. Is it okay if this video is posted to YouTube pretty soon, so I can like rewatch the second part of it, just so I can?
It's live, so it's already on there.
Okay.
So this, like, just go to the data, like U of U data channel, and there you will immediately see, like, as soon as I click stop, it's already on there.
Okay, that's easy. Thanks.
Excuse me, Professor.
Yeah.
I had a question with the first homework. So for redesigning, what I am planning to do is to have the data and use Microsoft Excel to do my redesign. Will that be acceptable?
Well, let me just switch off. This isn't something we need to record. And I'm going to